Okay, so we are talking about some of your open source research. So first, if you wouldn't mind just telling me a bit about how you got into open source in the first place, and maybe who you are.
Hi, so I'm Joshua Pearce. I'm an associate professor in materials and electrical engineering here at Michigan Tech. And let's see, I've been in open source a long time. So I started off in software, kind of where everybody else did. And the idea is if you share your code, others can build off of it, and we can all sort of collaboratively move forward much faster. And more recently, we've been getting into open source hardware, where you basically use the same sort of collaborative concepts that you see in open source software, only you're designing real physical objects. And so if someone does the CAD for something and you share it, the next person can then make a better whatever that thing is.
One of the specific things that you wanted to go over and what we wanted to talk about is why open source is important to scientists. So I know you've told me about how you got into specifically open source hardware in your lab, and I think that really tells the story of why it does matter to scientists.
Sure. So there's kind of two breakthrough moments for me, and the first one, we were working on a solar-powered laptop for the developing world, and we wanted to get the solar power part of it prototyped, just in plastic, just to hold the solar cells. And that ended up costing more than the laptop itself, and so it really became apparent that to do prototyping just was never going to work sort of in the developing world, let alone even for us. And so we were looking at different tools that we could use, and that was around the time when the open source RepRap project came out, which is an open source 3D printer that we could use to prototype our laptop case, but it can also prototype itself and via very high-end scientific equipment. And when, we've been playing with it in the lab, and when the light bulb really went off was when our filter wheel broke. And so the filter wheel just turns a filter and puts in path of a light beam that we were using to test solar cells. It's a very simple device, but it was automated so that our students didn't have to sit there and do it themselves. The device was going to cost $2,500 to replace. It had a huge lead time, like 5 months, because this isn't something they normally stock. There's probably 10 people in the whole world that want one. And so I hired a high school student who designed an open source filter wheel changer. Our version costs $50. It's better than anything commercially available on the market. You can customize it. You completely own it. And we shared it with the rest of the scientific community. So if anyone else ever has that same problem, they can make their own filter wheel for much, much less than they could ever get it commercially.
Now, of course, one of the challenges, I imagine, is that scientists require a lot of precision in the equipment that they use. So we want things to be of commercial quality. How does that work with open source technology?
So that's a big challenge, and that's where most of the effort goes into open source scientific hardware equipment. You have to validate it in some way, so there has to be some test to say if it's a filter wheel changer that it's moving the exact number of degrees that it says that it is. And we're using, commercial grade stepper motors that we're controlling with an open source microcontroller, but it's still just as good as what you'd ever have in industry. And in fact, in many ways, it's better because you can customize it to your own exact needs. Normally in science, we're trying to do something that no one else has ever done before. And one of the ways to do that is to use new equipment. So if you can just customize a piece of equipment slightly, you might be able to make the next great breakthrough. And then if it's shared open source hardware, everybody else can then follow you immediately and make the next breakthrough. So things should move a little faster.
Awesome. So what's the future of open source hardware and open source technology?
So I right now, when we started off, there was hardly any open source hardware for science. And now there's hundreds of things. Many labs are getting involved. And I think in the future, what you're going to find is every single experiment will have an open source hardware component that goes with it. So when you read about the latest breakthrough in science or nature in your own specialty journal, you can then download the plans, build the tool yourself, and immediately catch up to kind of where the state of the art is. And that's going to move every discipline faster. It'll make science better. The technology is better, and in the end, hopefully benefit all of humanity.
Awesome.
Great.
Okay. So speaking of awesome, we have to show this off for the recorder. We have open source technology earrings and logos. We got this.
All the way.
Michigan Tech.